You see, if I assume that x coordinate of a point on this line as t, then you can see that y coordinate is nothing but 4 minus t. So any point on the line is of this form. Now we want such points which are at a distance of 1 unit from this line. Now let us apply the distance formula. I'll have it as mod of 4t plus 3 into 4 minus t minus 10 by root of a square plus b square, which is 5. I want this distance to be 1. Such points I want. Now from this I have mod of, simplifying the numerator here, that's t 12, that is plus 2 is equal to 5 I get, or I have t plus 2 is equal to plus or minus 5, or I have t is equal to minus 7 or 3 I get. Now using this in this point, I'll have the points as minus 7 comma 11, or t, taking t equal to 3, I'll have it as 3 comma 1. And so option A is the answer. In this problem you can see that for different values of theta, the equation gives different lines. Let's first put this in the form lambda 1 L1 plus lambda 2 L2 equal to 0. For that, I'll write it as, taking cos theta common, 2x plus 3y minus 5, and then taking sin theta common, I have it as 3x minus 5y plus 2 is equal to 0. Now you simply solve these two equations, because it is like lambda 1 L1 plus lambda 2 L2 equal to 0, and we know that this represents a family of lines which pass through the intersection of these two lines, L1 equal to 0 and L2 equal to 0. Therefore you simply solve this and this, you will get your fixed point. This is an obvious one. You see, he said that this point lies on this, so it satisfies it. So I have 3a plus 2b is equal to 13, and this point lies on this. So I have 4b. As you can see, x is b this time and y is a. I'll have 4b minus a is equal to 5 I have. Now solving these two, I multiply this by a 3 for fun. I'll have minus 3a plus 12b is equal to 15. Now I add these two, I'm having it as 14b is equal to 28, or I have b is equal to 2. Now using b is equal to 2 in here, I have a is equal to 8 minus 5, that is 3. Therefore the points are nothing but P is a comma b, that is 3 comma 2, and Q is nothing but 2 comma 3. Now it's easy to find equation to the line joining P and Q, and which is obviously x plus y equal to 5. Now in this problem he gave us a triangle ABC. Suppose this is A 1 comma 1 and this is B 4 comma minus 2 and this is C 5 comma 5. Now what we want is, let's go for angle bisector of A, internal angle bisector of A. Suppose that is the internal angle bisector of A. And now from C we draw perpendicular onto this one. We draw perpendicular onto internal angle bisector. So we want this equation basically. Now we already have this point on this line. So if I know slope of this line, then I can find its equation. So all that I need is its slope. So for this slope, I'm going to give this slope. Okay, that is angle bisector slope. Now to find the slope of this one, I'm going to find one more point here. Namely, I'm going to find this point D here. Now we know that the angle bisector AD divides BC in the ratio AC is to AB. So find the length AC and find the length AB. So if you apply distance formula here, it will be root 16, 32, that will be 4 root 2 I am getting here. And similarly here if you apply distance formula, you are getting it as 3 root 2. Therefore, the ratio of the distance is nothing but 4:3. So we will find the coordinates of D such that D is dividing the CB in the ratio 4:3. So writing the coordinates of D, the coordinates of D will be 4, 4, 16, 16, 15. That's, I'm getting 31 by 7 comma minus 8 plus 15. So I'm getting 7 by 7, that will be 1. So the coordinates of D are 31 by 7 comma 1. Now if I go for the slope of this line, you can see that slope is 0. That means it is parallel to x-axis. That means this is parallel to, because this is perpendicular to that line, it is parallel to y-axis. Therefore its equation is nothing but x is equal to 5.